Okay, everybody. Sorry, I have my washing machine running, so if you hear something in the background, sorry about that. But this should not be too long of a lesson. It's just one page. um, okay, so let's take a look at this. Let's see. We're talking about solving quadratic equations using square roots. So here we have a quadratic equation. All right. Notice there's no middle term. It's just in the form y equals ax squared plus c. And notice, so what we're going to do is we're going to solve this using our algebra skills, right? And so you have to remember how to take square roots of stuff. Remember to use that square root button on your calculator. You are going to need your calculator for this. So here we go. 2x squared minus 98. We are going to try to solve this for x. So the first thing we're going to do is move the non-variable terms over. So that's going to be a plus 98 on both sides. So we have 2x squared is equal to 98. Then we divide by 2. We get x squared is equal to 49. Now, how do I take the opposite of x squared? We're going to take the square root. Remember, the square root is the opposite or the inverse of squared. Okay? So if I take the square root of both sides, the square root sign and the square sign cancel out. I get x on this side. Over here, I take the square root of 49. That one's pretty easy. That is just 7. So x is going to equal 7. Okay? One thing you have to remember, though, is when you take the square root, you can actually take the negative of that square root as well, right? So the answer is actually plus minus 7. Oops, plus minus 7 because positive 7 squared is 49 and negative 7 squared is 49, okay? All right, let's take a look at this. T minus 25 is equal to 0. This one's pretty easy. T squared minus 25 is equal to 0. And we're going to add 25 to both sides. Oops. To both sides. And we get t squared is equal to 25. So the square root of both sides is going to be t is equal to 5. But remember, negative 5 squared and positive 5 squared both come out to 25. So we're going to say it's plus minus 5. So before, we've talked about square roots before, and we only use the primary root, which is positive. But now we have to take into account the negative root. And we'll see why in a little bit. Okay? All right, so plus minus 5. Here it's a little bit more complicated, but not too much. 3a squared plus 12 is equal to 12 because before the other ones had 0, but let's see, minus 12, and we get 3a squared is equal to 0, right? And if I divide both sides by 3, you'll see that this comes out kind of weird. A squared is equal to 0, right? Well, we still take the square root of both sides. Take the square root of both sides, and we get a is equal to the square root of 0 is 0. Now, in this case, we don't need a plus minus because there is no positive or negative 0, right? It's just 0. Okay. Last one, we have 2g squared plus 32 is equal to 0. If we subtract 32 from both sides, we get 2g squared is equal to negative 32, and then divide by 2, and we get g squared is equal to negative 16, right? And so when we take the square root of both sides, we get g is equal to, let's see, is it 4? No, because 4 times 4 is positive 16. Is it negative 4? No, because negative 4 times negative 4 is also positive 16. Because this is a square of a negative number, it does not exist. There's no solution. No solution. There's no solution to a negative number. You can't have the square root of a negative number. Okay, so as soon as you get to this part where it's g squared is equal to negative 16, you know there's not going to be a solution. Okay? All right. So when we set up a quadratic equation equal to 0, we can solve for the x-intercepts of the equation. The x-intercepts are called the roots of the quadratic equation. By accurately graphing a quadratic equation using Desmos, etc., we can look at the x-intercepts to find the roots. Okay? So basically, if we have y is equal to x squared minus 3x plus 2, we can see that this thing crosses the x-axis at 2 and 1, right? What does that mean? This is when x is equal to 0, when y is equal to 0, then what are the values? Sorry, let me rewrite this. When y is equal to 0, what are the values of x that will give us y is equal to 0? Well, that's x is going to be equal to 1 and x is going to be equal to 2, right? Which makes sense because this thing is curved. Remember, it's symmetrical, it's curved, it's got two over things, and you can see that it intersects twice. That is why up here we have plus minus 7 and plus minus 5, okay? Because there are, in most cases for quadratics, there are two roots because you can see the way this thing works, right? What about for a equals 0? Well, in that case, what this thing actually looks like is this thing only touches the y-axis in one place, right? So that's what that looks like. What about for here? There's no solution. Well, this thing actually only touches the y-axis in 0 places. 0 places. So you can see this thing never not the y-axis, the x-axis. This thing only touches the x-axis in no places. It never touches the x-axis. So that's why there are no real solutions for here. Okay? So here we go. You get 0, only 1 because it only touches in one place. In both of these, what you will find is this thing touches in 2 places. This thing is going to look something like way down there. And this thing is also going to look like, and this point is going to be, negative 7, and this point is going to be positive 7. And this point is going to be negative 5 and positive 5. Okay? So we will definitely get more involved in this. We'll talk about this a little bit more. But yeah, that's basically what's happening here. Okay? So the roots are when y equals 0. So keep that in mind. But for right now, we're just solving these quadratics. Okay? That is it. Thanks for listening. Please ask questions if you need to. All right? I will see you guys later.